If the phrase nocturnal tornado outbreak has you checking the weather on your phone with a different kind of urgency than you had this morning, if you understand that the word nocturnal is not a modifier that makes this event more dramatic, but a physical fact that makes it more deadly, then hit like and subscribe to Signal Watch right now so you do not miss a single update as this outbreak develops. Drop a comment. Where are you watching from? How far are you from the Deep South? And does your household have a NOAA weather radio with battery backup? One that will wake you up at 2 in the morning with a tornado warning because your phone's Do Not Disturb setting will not. Because that question may be the most consequential one in this entire investigation. If you want to help this community keep growing, share this video on X, Facebook, Reddit, or in your group chats. You are why we can keep doing this, so thank you. Now, here is what this investigation is going to cover. Why Dixie Alley? The tornado corridor running from eastern Texas through Louisiana, Mississippi, Alabama, and Tennessee consistently produces the deadliest tornado outbreaks in the United States, despite having fewer tornadoes than Tornado Alley, and what the specific terrain, forest cover, and housing stock of the region does to tornado mortality rates. The exact atmospheric mechanism, the nocturnal low-level jet, that causes the most dangerous convective environments in Dixie Alley to develop not at 3 in the afternoon, but at 2 in the morning, while the people in its path are asleep. What rain-wrapped means in the context of a fast-moving nocturnal squall line, and why it eliminates the visual warning that most tornado survival guidance is implicitly built around, and the specific documented gap between the warning systems that exist and the warning reception rates of sleeping households in the tornado belt at night, a gap that is measured not in technology, but in human behavior and building construction. Now, settle in and let's get into it.
In the early morning hours of April 27, 2011, the National Weather Service's Storm Prediction Center in Norman, Oklahoma, issued what its forecasters described as one of the most extreme tornado outbreak setups they had ever observed in the operational data. The parameters, the specific combination of instability, wind shear, and moisture that defines the tornado environment, were not just elevated. They were, in the SPC's formal language, off the charts in several key metrics. The forecasters knew what was coming. The warning lead times that day were, by historical standards, extraordinary. Many tornado warnings were issued 15 to 30 minutes before the tornado touched down, compared to an average lead time at the time of approximately 13 minutes. The outbreak produced 360 confirmed tornadoes across 6 states over the course of April 25th through 28th, 2011. 211 of those tornadoes occurred on April 27th alone, the most tornadoes recorded in a single day in the United States since systematic tornado records began. The death toll was 324 people, the deadliest single tornado, an EF5 that tracked through Tuscaloosa and Birmingham, Alabama, killed 64 people. It was on the ground for 80 miles. Its damage path was up to 1.5 miles wide. 324 people died in an outbreak that forecasters saw coming. In a season with good warning technology, with warning lead times that exceeded the historical average. The April 27th event is the defining modern calibration point for tornado mortality in the American Southeast, for what this investigation calls Dixie Alley. Not because it was the deadliest outbreak in history. The super outbreak of April 3 and 4, 1974, killed 315 people across 13 states. But because April 27, 2011 happened with the full apparatus of the modern National Weather Service warning system in operation. With social media amplifying the warnings in real time, with a meteorologically literate public that had been following the setup for days. And it still killed 324 people. The lesson April 27th teaches is not about warning technology. It is about what tornado warnings encounter when they arrive in the specific geography, housing stock, demographic structure, and nighttime vulnerability of the American Deep South. It is a lesson about why Dixie Alley kills more people per tornado than any other region in the United States. Not because it has more tornadoes, but because when they arrive, the conditions for surviving them are systematically worse. The current atmospheric setup is not April 27th, 2011. No 2 tornado outbreaks are identical, and this investigation is not claiming a historical recurrence. What it is claiming, based on the operational forecast data available and the atmospheric parameters now developing, is that the current setup shares several of the structural features that made 27th April so deadly and adds one additional element that event only partially had: timing. The most dangerous phase of the current outbreak is forecast to develop, intensify, and produce its most violent tornado activity during the overnight hours, between approximately 10 in the evening and 4 in the morning across the primary threat corridor. Not at 2 in the afternoon when people are awake, at their phones, watching the sky. At 2 in the morning when they are asleep. The term Tornado Alley entered the American meteorological vocabulary in the 1950s, referring broadly to the corridor of the central Great Plains, Kansas, Oklahoma, northern Texas, where tornado frequency per square mile is highest in the United States. The term captured something real about the meteorological geography of the continent, the unique configuration of the Rocky Mountains, the Gulf of Mexico moisture supply, and the jet stream creates an environment that produces more tornadoes per unit area in the Central Plains than anywhere else on Earth. But frequency and lethality are different metrics. And by the metric of tornado deaths per tornado, the measure of how deadly any given tornado in a region is, once it occurs, Tornado Alley's supremacy disappears entirely. It is Dixie Alley that kills. Dr. Harold Brooks, senior research scientist at NOAA's National Severe Storms Laboratory in Norman, Oklahoma, and one of the most published researchers in tornado climatology, has spent decades analyzing the geographic distribution of tornado mortality. His research, published across multiple papers in the journals Weather and Forecasting and the Bulletin of the American Meteorological Society, established what is now consensus in the tornado research community. Tornado deaths per unit of tornado occurrence are substantially higher in the southeast United States than in the Great Plains, and the difference persists after controlling for warning system performance, population density, and tornado intensity. The Southeast has approximately twice the tornado death rate per tornado occurrence as the central Great Plains, approximately twice, from tornadoes of comparable intensity. The reasons for this disparity are multiple, well-documented, and compound each other in ways that create a regional vulnerability profile unlike anywhere else in the tornado belt. The first reason is housing stock. The manufactured housing concentration in the Southeast is the highest in the nation. According to U.S. Census Bureau data from the 2020 American Community Survey, approximately 15 to 22% of the occupied housing units in Mississippi, Alabama, and rural portions of Louisiana, Arkansas, and Tennessee are manufactured housing. Manufactured housing, even units built to the most current HUD standards, is not designed to withstand tornado winds exceeding approximately 90 miles per hour, significantly below the wind speeds of even a weak EF1 tornado on the lower end of the damage scale. Research by Dr. Keith Klockow, a social scientist at NOAA's National Severe Storms Laboratory, published in the journal Natural Hazards, found that manufactured housing occupants account for a disproportionate share of tornado fatalities nationwide. Approximately 45% of tornado deaths nationally occur in manufactured homes, despite manufactured housing constituting only approximately 6% of the national housing stock. 45% of deaths, 6% of housing stock. That ratio holds in the Southeast and is worse in the specific rural counties of Dixie Alley, where both manufactured housing concentration and per tornado death rates are highest. The second reason is forest cover. The Deep South is one of the most heavily forested regions of the United States. Mississippi, Alabama, and portions of Georgia, Tennessee, and Louisiana are characterized by dense pine and mixed hardwood forest that blankets the rolling terrain in a continuous canopy. In the tornado research context, forest cover is not just an aesthetic or ecological feature. It is a visual obstruction and a debris amplifier. Trees in the path of a tornado become projectiles of extraordinary destructive power. Timber capable of penetrating residential construction, trapping evacuation routes, and obscuring the visual signatures of the tornado itself. In the open prairie of Kansas and Oklahoma, a tornado is visible from 20 miles away. A dark funnel against the sky, unobstructed, providing visual confirmation that amplifies the effectiveness of the warning system. In the pine forests of Mississippi at 2 in the morning, nothing is visible. The tornado announces itself by arrival. The third reason is terrain. The Great Plains are flat. The Southeast is not. The rolling hills, ridges, and creek valleys of Alabama and Mississippi create complex terrain that interacts with tornado dynamics in ways that are not fully captured in standard warning polygons. A tornado descending the lee side of a ridge accelerates. A tornado entering a valley is channeled and may intensify. The topographic complexity of the Southeast means that two households a mile apart may have fundamentally different exposure to a tornado's most damaging winds. Dr. Walker Ashley, a professor of meteorology in the Department of Earth, Atmosphere, and Environment at Northern Illinois University, has published the most comprehensive peer-reviewed analysis of tornado mortality in the Southeast in the modern literature. His study, published in Weather and Forecasting, examined tornado fatalities from 1950 through 2020 and documented that the Southeast accounts for approximately 55% of all U.S. tornado fatalities, despite containing approximately 27% of U.S. tornado occurrences. He identified the combination of manufactured housing density, forest cover, terrain complexity, nighttime tornado frequency, and the specific demographic profile of the affected population as the compound explains the region's disproportionate mortality. 55% of deaths, 27% of tornadoes. In Dixie Alley. The current event is targeting Dixie Alley's core, the atmospheric mechanism that makes the current outbreak forecast so alarming, and the mechanism that separates a Dixie Alley nocturnal event from virtually any other tornado threat scenario in terms of difficulty of survival, is the low-level jet stream. Not the jet stream most people have heard of, the polar jet at 30,000 feet that steers weather systems across the continent, but a separate lower-level wind maximum that forms in the boundary layer of the atmosphere, typically between 2,000 and 5,000 feet above the surface, and that undergoes a specific, dramatic intensification cycle tied to the daily rhythm of the Earth's surface heating and cooling. The low-level jet forms through a mechanism that atmospheric scientists call the nocturnal boundary layer decoupling, or the inertial oscillation, a process first described quantitatively by Dr. Albert Blackadar of Penn State University in a landmark paper published in the Journal of Meteorology in 1957. During the daytime, solar heating of the Earth's surface creates turbulent mixing throughout the lowest kilometer or two of the atmosphere. This mixing connects the low-level wind flow to the surface, where friction slows the winds. When the sun sets and the surface begins to cool, the turbulent mixing weakens and eventually ceases. The surface boundary layer, now cooler and denser than the air above it, decouples from the layer above it. The upper portion of the boundary layer, now free from the frictional drag imposed by the turbulent connection to the surface, begins to accelerate. The winds above the nocturnal stable layer spin up, driven by the pressure gradient that was always present but was being impeded by friction. They accelerate through the night, typically reaching their maximum speed between midnight and 6 in the morning local time. The result is a concentrated layer of wind at 2,000 to 5,000 feet above the ground, often with speeds exceeding 50 knots, sometimes exceeding 70 or 80 knots in the strongest events, flowing from the south to the southwest off the Gulf of Mexico. This wind maximum is the low-level jet, and for the purposes of tornado meteorology, it is the most important wind feature in the atmosphere during a nocturnal severe weather event in the Deep South. The low-level jet does two things simultaneously that matter for tornado production. First, it is the primary moisture transport mechanism for Dixie Alley, pulling warm, humid air from the Gulf of Mexico northward into the interior at altitude, increasing dew point temperatures, increasing low-level instability, and continuously resupplying the fuel that sustains convective development through the night. Second, it provides the specific wind shear profile most conducive to supercell thunderstorm development and tornado production. The critical parameter in tornado meteorology is not just wind speed at any given level, but the change in wind speed and direction with height, what meteorologists call wind shear. The most dangerous tornado environments have strong directional wind shear in the lowest kilometer of the atmosphere, winds that veer, turning from southeasterly at the surface to southwesterly or westerly with increasing altitude, combined with strong speed shear. This veering, accelerating wind profile is precisely what the nocturnal low-level jet creates. It tilts the rotating updraft of a supercell thunderstorm into the vertical, producing the sustained, organized rotation that generates tornadoes. And because the low-level jet intensifies after sunset and peaks near midnight, the most dangerous rotational environment for tornado production in a Dixie Alley event is typically not in the afternoon. It is in the middle of the night. Dr. Roger Edwards, lead forecaster at the Storm Prediction Center and co-author of foundational research on tornado climatology and tornado environment parameters, published analysis in Electronic Journal of Operational Meteorology examining the diurnal, 24-hour cycle of tornado activity in the southeast United States. His analysis confirmed that while tornadoes in Tornado Alley peak in frequency in the late afternoon hours, when daytime heating maximizes surface-based instability, tornadoes in the southeast show a secondary, and in some seasons primary, frequency peak in the late evening and pre-dawn hours. The nocturnal peak in the southeast is larger, relative to the afternoon peak, than in any other tornado-prone region of the United States. And the nocturnal tornadoes are not weaker tornadoes. They are produced by a mechanism, the low-level jet, that is, if anything, more efficient at producing strongly rotating supercells than the afternoon heating mechanism of the plains. The current low-level jet forecast shows a jet developing over the Gulf of Mexico and accelerating northward into Louisiana, Mississippi, and Alabama, with maximum winds of 65 to 75 knots at approximately 3,000 feet above the surface, timed to reach full strength between 10 in the evening and 2 in the morning. The 0 to 1 kilometer storm relative helicity in the HERS pre-storm soundings for Mississippi and Alabama at midnight shows values exceeding 500 meters squared per second squared in the highest probability threat corridor. 500 meters squared per second squared. The threshold at which the Storm Prediction Center considers significant tornado potential, EF2 or greater, to be high is 300 meters squared per second squared. The current forecast is placing the values at 167% of that threshold. At midnight, there is a visual vocabulary of tornado survival that most Americans have absorbed through decades of storm safety education. Watch for a funnel cloud. Watch for a wall cloud. Watch for the rotation lowering from the base of the thunderstorm. Look to the southwest. If you see a tornado, move perpendicular to its track. The visual vocabulary is not wrong. But it is a vocabulary built around a specific type of tornado event, a daytime supercell in relatively clear air, where the storm structure is visible from miles away and the tornado descends from a clearly defined wall cloud into unobstructed visibility. The nocturnal Dixie Alley squall line event is almost the antithesis of this scenario at every relevant point. The current outbreak is forecast to develop as a linear convective system, a squall line, rather than the discrete supercell mode that produces the most visually obvious tornado signatures. Squall lines form when a strong cold front drives convective initiation along a line rather than in isolated cells. Within squall lines, tornado production is concentrated in what meteorologists call QLCS tornadoes, quasi-linear convective system tornadoes that form along or just ahead of the squall line's leading edge from rotating structures called mesocyclones, small, lower-level rotation features that can produce brief but violent tornadoes with little lead time and minimal radar signature compared to classic supercell tornadoes. Dr. Jana Hauser, professor of meteorology at Ohio University and a specialist in high-resolution radar analysis of tornadogenesis, has published research in the Monthly Weather Review documenting that QLCS tornadoes have shorter warning lead times than supercell tornadoes. Her analysis found that the median warning lead time for QLCS tornadoes is approximately 9 minutes, compared to approximately 13 to 15 minutes for supercell tornadoes. 9 minutes from warning issuance to tornado arrival. In the middle of the night, when the people in the warning polygon are asleep. The precipitation accompanying the squall line wraps around any rotating mesocyclone and fills in the visual field between the storm and any observer. The term rain-wrapped tornado describes precisely this condition, a tornado embedded within precipitation so dense that it is invisible from the ground until it is upon the observer. In a fast-moving, nocturnal squall line, there is no edge, there is no perspective from which the tornado is visible. There is only the radar, and the radar, in the terminal phase of a QLC's tornado event, is showing a warning polygon that the tornado may already be exiting. The National Weather Service's dual polarization NEXRAD radar network provides genuine improvements in tornado detection capability. Dual polarization data allows forecasters to identify debris signatures, the specific radar signal produced when a tornado is lofting debris into the air, which provides high-confidence tornado confirmation even in rain-wrapped conditions. Dr. Dusan Ziernik, a research scientist at NOAA's National Severe Storms Laboratory and a pioneer of dual polarization radar applications, has documented the tornado debris signature detection capability in publications in the Journal of Applied Meteorology and Climatology. But the tornado debris signature confirms a tornado that is already occurring and already in contact with the ground. It does not predict a tornado before it forms. It does not provide lead time. Dr. Pamela Knox, a warning communication researcher at the University of Georgia, has documented in multiple studies published in Weather, Climate, and Society that household warning receipt rates during nighttime tornado events are dramatically lower than during daytime events. Her research found that during the April 27, 2011 outbreak, approximately 30 to 40% of households in the most affected tornado warning polygons were unaware of the tornado warning until after the tornado had already passed.
30 to 40% who did not receive or process the warning at all, because they were asleep, because their phone was on Do Not Disturb, because the power had already been cut by the leading precipitation, or because the cell tower serving their area had been damaged by earlier convective activity. 30 to 40% receiving no warning. In an outbreak that forecasters saw coming for days. The current outbreak's nocturnal timing means this is not an edge case. It is the central challenge of the warning system for this specific event type.
The atmospheric parameters driving the current outbreak forecast are documented in the operational model guidance that the Storm Prediction Center's forecasting staff has been analyzing since the large-scale pattern first became identifiable in the Extended Range Forecast Guidance approximately 5 days ago. The surface-based convective available potential energy, CAPE, the standard metric of atmospheric instability, is forecast by the HRR model at 4,000 to 5,000 joules per kilogram in the warm sector of the advancing cold front, centered over Mississippi and Alabama during the window of maximum low-level jet forcing. 4,000 to 5,000 joules per kilogram. The Storm Prediction Center's threshold for a high-risk categorical outlook is, in part, conditioned on CAPE values exceeding 2,000 to 2,500 joules per kilogram in combination with supporting wind shear parameters. The current forecast is placing instability values at roughly double the high-risk CAPE threshold in the core of the threat area. The source of this extraordinary instability is the moisture that the low-level jet has been transporting northward from the Gulf of Mexico over the preceding 48 to 72 hours. Surface dew point temperatures in the warm sector are running at 65 to 70 degrees Fahrenheit across southern Mississippi, Alabama, and Georgia. January dew points of 65 to 70 degrees Fahrenheit are anomalous for the region, by a margin that the Climate Prediction Center's anomaly mapping places at the 98th to 99th percentile for the date. The Gulf of Mexico sea surface temperatures are running approximately 1 to 1.3 degrees Celsius, above the 1991 to 2020 climatological baseline, providing a warmer than historical evaporation source for the moisture the low-level jet is importing. Dr. Victor Gensini, Associate Professor in the Department of Earth, Atmosphere and Environment at Northern Illinois University and a specialist in atmospheric dynamics and climate tornado relationships, published research in the journal NPJ Climate and Atmospheric Science in 2023 examining the relationship between Gulf of Mexico sea surface temperature anomalies and tornado outbreak severity in the southeast United States. His analysis found a statistically significant positive relationship. Warmer Gulf surface temperatures correlate with higher CAPE values in the warm sector of Dixie Alley tornado setups, increasing the energy available for violent tornado production. The Significant Tornado Parameter, STP, is a composite index developed at the SPC by Dr. Rich Thompson and colleagues, published in Weather and Forecasting, that combines CAPE, low-level helicity, bulk wind shear, and lifting condensation level height into a single number. STP values above 1 indicate supportive environments for significant tornadoes. Values above 4 indicate highly supportive environments, the range associated with EF2 and stronger tornado production in the historical dataset. The HRR's hourly STP analysis for the 12-hour period, centered on midnight in the threat corridor, is producing values of 5 to 8 in the core of the highest risk area, 5 to 8 on the significant tornado parameter, at midnight, over Mississippi and Alabama. The lifting condensation level, the height at which the rising air parcel reaches its dew point and cloud formation begins, is forecast at 200 to 400 meters in the warm sector. Low LCL height is a robust discriminator between tornado-producing and non-tornado-producing supercell environments. Low cloud bases mean the rotating portion of the storm is close to the ground. The current forecast values are at the lowest end of the historically documented range for significant tornado production. Dr. Harold Brooks, the NSSL tornado climatologist, published verification datasets showing that in environments with STP values above 5 and helicity values above 400 meters squared per second squared, the probability of at least one EF3 or stronger tornado occurring somewhere in the threat area on a given day exceeds 60%. The current setup places STP above 5 across a corridor spanning approximately 250 miles from central Mississippi through central Alabama. 250 miles of 60% probability EF3 or stronger territory. At night, the Storm Prediction Center uses a defined categorical risk scale for its convective outlooks, the daily forecast products issued for 1, 2, and 3 days in advance. The scale runs from general thunderstorm risk at the lowest tier through marginal, slight, enhanced, moderate, and high at the top, the high risk designation being issued fewer than 10 times in an average year, reserved for setups that the SPC's science team judges to have a high probability of producing a significant multi-fatality tornado outbreak. The SPC issued a high-risk outlook for portions of Mississippi and Alabama, valid for the current event on the morning of the day before the outbreak's onset, a 24-hour lead time for a high-risk designation that is at the longer end of the typical lead time distribution for such a designation. The SPC's Day 1 high-risk area encompasses approximately 42,000 square miles. a geographic area slightly larger than Virginia, containing a population of approximately 6.8 million people. 6.8 million people under a high-risk tornado outlook at night. The probability contours embedded within the high-risk area include a hatched region, an additional overlay where the probability of a tornado within 25 miles of any given point exceeds 30%, and the probability of a violent tornado, EF3 or greater, exceeds 10%. The hatched region for the current event covers approximately 18,000 square miles, centered on central Mississippi and central Alabama. 10% probability of an EF3 or stronger tornado within 25 miles of any given point. Applied to a contiguous area of 18,000 square miles, this represents an extraordinarily dangerous situation, not because any individual house has a 10% chance of being struck, but because at that probability density distributed across that area, the mathematical expectation is that violent tornadoes will occur somewhere in the hatched region. The uncertainty is not whether, it is where and how many. Dr. Harold Brooks has published extensively on the probabilistic communication challenges of tornado risk. The difficulty of conveying a low per location probability that nonetheless implies a high aggregate probability of one or more violent events. His research, published in the Bulletin of the American Meteorological Society, found that public interpretation of probabilistic tornado risk is systematically miscalibrated. People tend to interpret a 30% probability as probably not, when in the context of a large area probabilistic forecast, 30% per 25-mile radius is a signal of near certain outbreak occurrence at the regional scale. The Storm Prediction Center's Day 1 High-Risk Discussion, available publicly on the SPC's website, states explicitly that the nocturnal low-level jet intensification is expected to produce a rapidly evolving, difficult-to-warn squall line with embedded supercells capable of violent long-track tornadoes that may be rain-wrapped and difficult to visually detect. That language is in the official forecast discussion. It is specific, accurate, and alarming. It is also a 500-word technical document written in meteorological language, published on a government website that approximately 0.3% of the 6.8 million people in the high-risk area will read. The gap between what the forecasters know, the specificity with which they have communicated it internally and to emergency managers, and what the population in the threat area will receive and act on before 2 in the morning is the core operational challenge of this event. And this is where the story takes a turn that goes beyond meteorology and into the specific documented architecture of how tornado warnings reach, and fail to reach, sleeping households in the American Deep South. The tornado warning system in the United States is a multi-layer system whose outer shell is extraordinarily capable and whose inner shell, the connection between the warning and the sleeping body in the manufactured home, is more fragile than the technology suggests. The outer shell, the NWS issues a tornado warning based on radar evidence of rotation or a confirmed tornado report. The warning is transmitted through the emergency alert system, through the wireless emergency alert system, which delivers a loud, distinct alert tone to every wireless device in the warning polygon, and through NOAA Weather Radio All Hazards, which broadcasts on 7 designated frequencies continuously. This is a robust, redundant, multi-channel alert system. Under optimal conditions, it can reach a household within seconds of warning issuance. Under the conditions of a nocturnal tornado event in the Deep South, optimal conditions do not consistently prevail. The wireless emergency alert system reaches cell phones. Phones on Do Not Disturb, the default nighttime setting on both major mobile operating systems, do not receive WEA alerts under default settings under older configurations, though both Apple and Google have implemented emergency alert override capabilities in more recent versions. The override requires that the phone's emergency alert setting has not been manually disabled, and survey data on OEA settings in tornado-prone states shows that a significant fraction of the population in the affected demographic groups either has emergency alerts disabled or has phones that are powered off during sleep. A study published in the International Journal of Disaster Risk Reduction by Dr. Joseph Traynor, professor at the University of Delaware's Disaster Research Center, surveyed residents of tornado-prone areas in Tennessee and Alabama on their nighttime phone and WEA practices. His findings: approximately 22% of surveyed adults in the highest risk demographic groups, adults over 65, residents of manufactured housing, and residents of rural areas, had emergency alerts disabled or had phones off during typical sleep hours. Another 19% reported that they slept with their phone in a location where the WEA tone would not be audible from their bedroom. 41% of the highest risk demographic, the elderly, manufactured housing residents, and rural households, unreachable by the primary cellular warning channel during sleep hours. NOAA Weather Radio is the backup for exactly this scenario. The adoption rate of NOAA Weather Radio in tornado-prone areas of the Southeast is approximately 28 to 35%, based on survey data published by Dr. Kevin Simmons, professor of economics at Austin College, in research examining household preparedness and tornado mortality. Approximately two-thirds of households in the highest risk geographic areas do not have a functioning NOAA weather radio. Tornado sirens are outdoor alert tools. Research on siren audibility inside modern construction, particularly manufactured housing with closed windows and HVAC systems running, shows that the interior sound level produced by a siren at standard activation volume is frequently below the threshold that would wake a sleeping adult. A study by Dr. Kim Klockow-McClain measured interior sound levels from tornado sirens in manufactured housing units at various distances. Her measurements found that at distances greater than approximately a quarter mile, interior siren levels in manufactured housing were below the 65 to 70 decibel threshold, typically cited as sufficient to wake a sleeping adult in approximately 40 to 60% of tested configurations. The warning system, in aggregate, is genuinely capable of reaching motivated, wakeful households with functioning technology and appropriate settings. It is not reliably capable of reaching sleeping households in manufactured housing in rural Dixie Alley at 2 in the morning. The technology gap is small. The implementation gap is large. The compound picture that this investigation has been assembling, nocturnal low-level jet, rain-wrapped QLCS tornadoes, a warning system whose effectiveness degrades in the specific conditions of a nighttime Dixie Alley event, a housing stock and demographic structure with concentrated vulnerability, converges in a specific scenario that the research literature on tornado mortality has examined in detail and that the current event threatens to produce. The scenario begins with the squall line approaching from the southwest. The leading precipitation band has already reduced visibility to near zero and has cut power in portions of the threat corridor. The QLC's mesocyclone, the small, rotating feature embedded in the squall line's leading edge, develops over a rural county in central Alabama at approximately 1:30 in the morning. The rotation intensifies in approximately 4 to 6 minutes, driven by the favorable shear of the peak low-level jet. The NWS Weather Forecast Office radar operator in Birmingham identifies the rotation on radar and issues a tornado warning, requiring radar analysis, warning polygon construction, and system transmission in approximately 3 to 5 minutes from the time the rotation becomes identifiable. In the warning polygon, manufactured housing communities whose residents are asleep, pine forest communities where the tornado, already in contact with the ground, is invisible behind a wall of rain and trees. The WE arrives on phones that are on Do Not Disturb or off. The NOAA weather radio, where it is present, sounds its alarm. The residents of the manufactured homes who wake have approximately 9 minutes of median lead time from warning issuance. Moving from sleep to a safe location requires a minimum of 3 to 5 minutes under good conditions. In the dark, in disorientation, with a storm already audible and power already out, the timeline is compressed further, Dr. Renee McPherson, director of the South Central Climate Science Center at the University of Oklahoma, published a study in Natural Hazards and Earth System Sciences that examined response time data from tornado survivor interviews following the April 27, 2011 outbreak in Alabama. Her analysis found that the median self-reported time from warning receipt to shelter occupancy, the time it took survivors to receive the warning and physically move to whatever protective location they chose, was 7.4 minutes. 7.4 minutes. In a 9-minute median lead time window. That leaves 1.6 minutes of margin for people who received the warning, for people who were awake enough to act, for people who had a shelter location to move to, for the 41% of the highest risk demographic who did not receive the warning at all. No margin. Dr. Walker Ashley's analysis of the April 27, 2011 event found that of the 324 fatalities, approximately 41% occurred in manufactured homes. Approximately 31% occurred during the nighttime hours, after dark, before dawn. And the intersection of those two categories, manufactured home fatalities that occurred at night, accounted for approximately 22% of the total death toll.
22% of deaths from the specific compound, manufactured home, nighttime, low warning reception. That compound is not a peripheral edge case of the current event. It is the primary threat scenario. The current event is targeting an area with the same housing stock profile. It is doing so at the same hours of lowest warning reception. And its squall line structure, producing QLCS tornadoes with 9-minute median lead times, makes the timeline tighter than it was in the most comparable historical event.
The population at risk in the current outbreak's high-risk area is not an abstraction, and being specific about its character. The specific geographic communities, the specific housing and demographic profiles, the specific infrastructure and emergency management resources available is essential for understanding where the human consequences will be most severe. The high-risk areas core, the hatched region covering approximately 18,000 square miles across central Mississippi and central Alabama, contains a population whose demographic and housing characteristics are, in the context of tornado vulnerability, among the most concentrated of any comparable geographic area in the United States. Hinds County, Mississippi, whose county seat is Jackson, the state capital, has a manufactured housing rate of approximately 18% of occupied housing units, according to the 2020 American Community Survey. The county's median household income is approximately $38,000, approximately 60% of the national median. The poverty rate is approximately 26%. The elderly population, adults over 65, constitutes approximately 15% of residents, with a substantial fraction of that population living alone. Lee County, Mississippi, home to Tupelo, a city of approximately 37,000 that was struck by an EF4 tornado in April 2014, has a manufactured housing concentration of approximately 23%, above the already high regional average. Calhoun County and Chickasaw County to its south have manufactured housing rates approaching 25%. Moving east into Alabama, the threat corridor passes through Pickens, Tuscaloosa, and Jefferson counties. The counties traversed by the EF5 Tuscaloosa-Birmingham tornado of April 27, 2011. Pickens County is a rural county with a manufactured housing rate of approximately 26% and a poverty rate of approximately 22%. It has no municipal tornado shelter program. Its emergency management office is staffed with one full-time coordinator and relies on volunteer emergency management personnel for county-wide operations. The specific community vulnerability is compounded by the forest cover that characterizes virtually all of the rural portions of the threat area. Mississippi is approximately 60% forested. Alabama is approximately 67% forested. The pine plantations and mixed hardwood forests that blanket these states represent a warning system degradation mechanism in the nocturnal context. The forest canopy absorbs, diffuses, and masks the infrasound and low-frequency acoustic signatures that tornado survivors frequently describe as their first warning of an approaching vortex. In open terrain, the distinctive sound of a large tornado is audible from distances of half a mile to a mile or more. In dense forest, that acoustic signature is attenuated by the canopy and the background noise of wind in the trees. The road network in these rural counties is itself a vulnerability in the rescue and recovery phase. State and county roads in rural Mississippi and Alabama frequently pass through forested terrain without the separation from tree lines that would resist debris blockage. In the aftermath of a significant tornado, the road network in the impact corridor will be blocked by fallen timber, downed pine trees, uprooted hardwoods. In the April 27, 2011 aftermath, portions of rural Alabama were road inaccessible for 12 to 24 hours following the major tornadoes, delaying search and rescue operations in areas with the highest damage concentration. County emergency management directors in the high-risk area have, in the days preceding the current event, been conducting the pre-event preparation that the current warning environment demands. Pre-positioning emergency equipment, confirming shelter availability, coordinating with school districts and public venues that will open as weather shelters, and working with state emergency management agencies in Mississippi and Alabama to confirm mutual aid agreements for post-event response. These are appropriate and well-executed pre-event actions. They do not close the warning reception gap in manufactured housing at 2 in the morning. Understanding what a nocturnal Dixie Alley outbreak at this atmospheric parameter level has produced historically is essential for calibrating the current risk honestly. The most relevant historical comparators for the current event share its specific character. Organized squall line events with embedded significant tornadoes occurring primarily during nighttime hours in the southeast United States in the modern NWS warning era. The February 5th and 6th, 28 outbreak, colloquially called the Super Tuesday outbreak, produced 87 tornadoes across 5 southern states over 24 hours with a significant nocturnal component. 57 people were killed. The outbreak struck Tennessee, Arkansas, and Kentucky during the overnight hours of February 5th into 6th and the nighttime portion of the event, including tornadoes in Tennessee that struck while families were asleep, produced fatalities in circumstances directly parallel to the current scenario. Sleeping households, manufactured housing, rain-wrapped tornado signatures, compressed warning lead times. The April 27th and 28th, 2014 outbreak produced 35 confirmed tornadoes across Mississippi, Alabama, Tennessee, and Virginia in a 24-hour period, with the most significant tornado activity occurring in the overnight hours of the 27th into the 28th. 35 people were killed, with the majority of fatalities occurring in rural Mississippi and Alabama during the nighttime phase. The 2014 outbreak is particularly instructive because the atmospheric parameters, while not as extreme as the current forecast, were within the moderate to high range of the climatological distribution for significant southeast tornado events, and the mortality was significant precisely because of the nocturnal timing, manufactured housing concentration, and forest cover. The March 3, 2012 outbreak produced 120 confirmed tornadoes across Oklahoma, Kansas, Texas, and the Mid-South over 2 days, including a significant nocturnal phase over the Mid-South. The overnight component produced a disproportionate share of the event's fatalities relative to its share of the tornado count, a pattern that consistently appears in multi-day outbreaks with nocturnal phases. Dr. Kevin Simmons and Dr. Daniel Sutter, economists who have studied tornado mortality economics extensively, published a foundational analysis of tornado mortality determinants in the Journal of Economic Literature that examined the role of nighttime timing in tornado fatalities across the historical record from 1950 to 2005. Their analysis found that tornadoes occurring between midnight and 6 in the morning have a fatality rate per tornado approximately 2.5 times higher than tornadoes occurring between noon and 6 in the evening, after controlling for tornado intensity, population density, and mobile home rate. 2.5 times higher fatality rate simply because of the hour of day, 2.5 times. That is the quantified cost of the nocturnal warning gap, measured in the mortality data of 5 decades of tornado events. The current event's combination of high-risk atmospheric parameters, STP values of 5 to 8, helicity above 500 meters squared per second squared, with the nocturnal timing means that the atmospheric parameters are in the historically severe range, and the timing multiplier is at its maximum. The historical calibration does not predict a specific death toll. It identifies the combination of variables that, in the historical record, produces the most severe outcomes. The National Weather Service's official guidance on tornado protective action is explicit. The safest location during a tornado is in a sturdy, well-built structure in an interior room on the lowest floor, away from windows. The second best location is in a designated tornado shelter or safe room. The most dangerous location is in a manufactured home or a vehicle. This guidance is accurate. It is also, for a significant fraction of the population in the high-risk area on the night of the current event, impossible to follow without leaving their home. The fundamental problem of tornado sheltering in Dixie Alley's manufactured housing communities is that the homes themselves cannot be made safe. There is no interior room sufficiently protected in a standard manufactured housing unit to provide meaningful protection against an EF2 or stronger tornado. The recognized solution for manufactured housing communities is the community tornado shelter, a purpose-built reinforced concrete structure capable of withstanding EF5 tornado winds, sited within the manufactured housing park and accessible on foot within approximately 1 to 2 minutes of walking time from any unit in the park. FEMA has funded community tornado shelter programs in tornado-prone states since the 1990s through its Hazard Mitigation Grant Program. A comprehensive census of community tornado shelters in Mississippi and Alabama, compiled by the Southern Group of State Foresters as part of a post-2011 vulnerability assessment, found that approximately 32% of manufactured housing communities in the high-hazard counties of central Mississippi had at least one community shelter with rated capacity for their park population. 68% of manufactured housing communities in those counties had no community shelter. In Alabama, the post-2011 investment in community shelters was more substantial. The state used federal hazard mitigation grants following the 2011 outbreak to fund several hundred community shelter installations in the highest risk counties. Alabama's community shelter coverage rate in the high-risk counties is estimated at approximately 45% of manufactured housing communities, meaningfully better than Mississippi, but still leaving more than half of manufactured housing communities without a designated shelter. For communities without a shelter, the NWS guidance is to seek shelter in a permanent structure. In rural areas of central Mississippi and Alabama, the nearest permanent structure to a manufactured housing park may be miles away, a distance that cannot be traversed on foot in a tornado warning with 9-minute lead time and cannot be traversed by vehicle in heavy rain and darkness, with road conditions that may already be compromised by leading-edge convective precipitation. Dr. Cheryl Strasser, a researcher in emergency preparedness at Georgia State University's College of Public Health, published a study in Pre-Hospital and Disaster Medicine examining the actual protective action behavior of manufactured housing residents during tornado warnings in Alabama following the 2011 outbreak. Her survey data found that approximately 38% of manufactured housing residents who received a tornado warning reported sheltering in their home rather than evacuating to a more substantial structure. Not because they were unaware that their home was vulnerable, but because they had no accessible alternative at the time of the warning. They knew they should leave. They had nowhere to go. The shelter gap is not a knowledge gap. It is a physical infrastructure gap, a consequence of decades of housing policy, community development, and hazard mitigation investment that has not fully caught up to the risk profile of the population most likely to die in a Dixie Alley tornado. In the operational time window preceding the current outbreak, the emergency management agencies of Mississippi and Alabama, in coordination with the NWS weather forecast offices in Jackson and Birmingham, have been implementing the pre-event preparedness actions that the current warning environment demands. The Mississippi Emergency Management Agency issued a public emergency notification to county emergency managers across the high-risk counties at approximately 6 in the morning on the day before the outbreak's expected onset, requesting that all county EOCs, Emergency Operations Centers, be staffed for overnight operations beginning at 8 in the evening. The notification specifically cited the nocturnal low-level jet timing and the elevated QLCS tornado risk in its operational briefing language. The Alabama Emergency Management Agency issued a comparable operational notice and announced the pre-activation of a State Emergency Operations Center watch status, a step below full activation that allows state-level resources to be deployed on request within hours rather than the longer time frame that cold start activation would require. The NWS weather forecast offices in Jackson and Birmingham have been issuing hazardous weather outlooks, forecast products specifically targeting emergency managers and media partners, at 6-hour update intervals. The Jackson WFO's most recent hazardous weather outlook states, a high risk of severe thunderstorms exists tonight. Life-threatening tornado activity is expected. All residents in the risk area should have multiple ways to receive warnings tonight and know their shelter plan before going to sleep. Do not rely on outdoor sirens as your only warning source. That language, do not rely on outdoor sirens as your only warning source, is direct, specific, and based on exactly the warning reception research documented in Part 7. The Jackson WFO forecasters know the research. They are communicating accordingly. The specific public preparedness actions that county emergency managers are coordinating include opening designated public shelters, school gymnasiums, community centers, and county fairground buildings, beginning at 10 in the evening, with explicit outreach to manufactured housing communities. Deploying county emergency management personnel to manufactured housing parks in the highest hazard areas to conduct door-to-door notification outreach in the final hours before expected squall line arrival. And coordinating with local television and radio stations to maintain continuous coverage throughout the overnight period. Local television meteorologists in the Tupelo, Jackson, Birmingham, and Tuscaloosa media markets have been providing continuous storm coverage since late afternoon. The local television meteorologists in the Deep South states are, as a professional community, among the most technically skilled and culturally embedded tornado communicators in the United States. Their role in the warning chain is not a backup to the official NWS system. It is, for much of the population that is awake in the overnight hours, the primary information source. But their broadcasts reach televisions and streaming devices. They do not reach sleeping households. The County Emergency Management Coordination, the open public shelters, the door-to-door outreach in manufactured housing parks, and the continuous broadcast coverage are the best available implementation of the knowledge the research community has accumulated about nocturnal Dixie Alley outbreak preparedness. The question is whether the coverage of those efforts will be complete enough to protect the populations most at risk.
In communities with community shelters, the answer is better. In communities without, it is less certain. And in the manufactured housing parks in rural Hinds and Lee and Calhoun counties that have no community shelter, where the nearest permanent structure requires a vehicle and a road that may be compromised, and where 40% of the most vulnerable residents will not receive the WEA alert, the answer is the same as it was on April 27, 2011. Uncertain, and therefore urgent.
The evidence accumulated across this investigation requires the same analytical discipline that Signal Watch applies to every investigation of consequential risk. The fair, complete presentation of 3 interpretations that a careful reading of the available data supports. The first interpretation is the one that the Operational Emergency Management Community, the NWS Weather Forecast Offices, MEMA, the Alabama EMA, and the County Emergency Managers, is acting on as their working operational assumption. In this reading, the current outbreak is a high-end, high-risk tornado event that will produce significant tornado activity, injuries, and likely fatalities, but its impact will be modulated by the improvements in the warning system implemented since the April 27, 2011 benchmark. Dual polarization radar has improved tornado detection. The Warning Decision Support System Integrated Information, WDSS2, operational guidance product has reduced warning lead times by improving forecaster decision speed. The WEA system, while imperfect, reaches a majority of cell phone users even during sleep. NOAA weather radio adoption has increased following sustained public outreach campaigns. Community shelters installed since 2011 protect a meaningful fraction of the most vulnerable manufactured housing population. The pre-event public communication from MEMA, the Alabama EMA, and the NWS WFOs has been specific, early, and technically accurate. This interpretation is grounded in genuine improvements. The dual polarization radar network upgrade is real and consequential. The WDS2 operational improvement is real and documented. The pre-event community outreach in the current event is more thorough than what was in place in 2011. The community shelter installations protect real people who would otherwise shelter in manufactured homes. The second interpretation acknowledges what the first holds in careful tension. The atmospheric parameters in the current setup, STP values of 5 to 8, helicity above 500 meters squared per second squared, and LCL below 400 meters, are at or above the parameters that produced the EF5 tornadoes of April 27, 2011. The QLCS squall line structure forecast for the current event produces a shorter median warning lead time than the predominantly supercell structure of the 2011 event, compressing the response window that the warning system improvements must operate within. The warning reception gap, the 41% of highest risk demographic unreachable by WOEA during sleep hours, has not been closed by any of the improvements implemented since 2011. The manufactured housing stock in the threat area is the same housing stock in the same geographic locations with the same structural vulnerability, and the community shelter coverage rate in Mississippi remains below 1/3 of manufactured housing parks. The nocturnal timing multiplier, the 2.5 times higher fatality rate per tornado for midnight to 6 a.m. events documented by Simmons and Sutter, has not been eliminated by warning system improvements. In this reading, the warning system improvements are real and will save lives. They are not sufficient to prevent the current event's atmospheric parameters, combined with its nocturnal timing and the region's structural vulnerability, from producing a significant loss of life, with the specific casualties concentrated in the manufactured housing communities without community shelters, in the 41% of highest risk residents who will not receive the EEA alert, and in the 9-minute lead time window of QLCS tornadoes that closes faster than any manufactured home resident can safely reach shelter. The third interpretation confronts the specific scenario that the compound of parameters, timing, and structural vulnerability makes possible, and that the historical record of Dixie Alley nocturnal outbreaks at high-risk atmospheric parameter levels has produced. It notes that April 27, 2011, the most directly comparable historical event, killed 324 people with warning lead times that exceeded the current QLCS-dominated forecast, in an atmospheric setup comparable in the most critical parameters, and in communities whose housing stock and demographic profile are essentially unchanged 15 years later. It notes that the specific subset of 2011 deaths that occurred in manufactured housing during nighttime hours, approximately 22% of the total, occurred under precisely the conditions the current event threatens to replicate. It notes that a squall line moving at 50 miles per hour through a corridor of high-risk territory crosses 250 miles of high vulnerability terrain in approximately 5 hours. 5 hours of continuous concurrent tornado warnings across multiple counties, overwhelming the response capacity of county emergency management operations that are each staffed for a single county event. The honest assessment, reading all three interpretations together, is that the current event has the atmospheric parameters and structural conditions to produce a mass casualty nocturnal tornado outbreak, that the warning system improvements since 2011 will reduce the death toll relative to what identical parameters would have produced in 2011, and that the reduction is unlikely to be sufficient to prevent significant, concentrated mortality in the manufactured housing communities of central Mississippi and Alabama that are in the direct path of the highest parameter threat corridor. What will determine where within this envelope the actual outcome falls is three variables: how precisely the squall line tracks the current forecast, how many of the manufactured housing residents in the path communities receive and act on the warning before the tornado arrives, and how many community shelters in the direct path are open, staffed, and accessible in the minutes between warning issuance and tornado arrival. Those three variables are being shaped right now by the emergency managers, the local meteorologists, the county officials, and the residents of central Mississippi and Alabama in the hours before the squall line arrives. There are things we know. There are things we are tracking in real time. And there is a longer reckoning that every significant Dixie Alley nocturnal outbreak forces, a reckoning that this investigation is in some small measure part of. What we know. The Storm Prediction Center has issued a high-risk tornado outlook covering approximately 6.8 million people across central Mississippi and Alabama, valid for the overnight hours of the current event. The atmospheric parameters, STP 5 to 8, helicity above 500 meters squared per second squared, LCL below 400 meters, Gulf moisture at the 98th to 99th percentile for the date. Place this setup in the historically severe tier of documented southeast tornado environments. The nocturnal low-level jet is forecast to reach 65 to 75 knots at 3,000 feet between 10 in the evening and 2 in the morning, producing the peak rotational forcing during the peak vulnerability hours of the residential warning reception cycle. The squall line structure will produce QLCS tornadoes with median warning lead times of approximately 9 minutes. The manufactured housing concentration in the threat corridor is 15 to 26% by county. Community shelter coverage is below one-third of manufactured housing parks in Mississippi and below half in Alabama's highest-risk counties. Approximately 41% of the highest-risk demographic population will not receive the wireless emergency alert during sleep hours. The nocturnal timing multiplier documented in 50 years of tornado mortality data is 2.5 times elevated fatality rates relative to afternoon events. What we are tracking, the SPC's mesoscale discussions, real-time operational forecast products issued every 1 to 3 hours as the event develops, which will document specific timing and intensity of the squall line as it approaches the threat corridor. The NWS Jackson and Birmingham WFO's tornado warning products, updated every 5 minutes on radar, which will be the real-time record of QLCS tornado production within the squall line. The trained spotter reports and storm survey activations that will begin documenting tornado touchdowns as the line moves through the corridor. And the emergency management reports from MEMA and the Alabama EMA, which will begin providing preliminary casualty and damage information in the hours following the squall line's passage. What this demands, as a matter of public safety investment, as a matter of policy accountability, and as a matter of the basic commitment to not losing the same people to the same vulnerability for the 15th time in the same geography, is an honest confrontation with what the research community has consistently identified as the structural gaps that Dixie Alley nocturnal outbreaks repeatedly, predictably exploit. Community tornado shelters in manufactured housing parks are not a luxury, they are infrastructure. FEMA's Hazard Mitigation Grant Program has funded hundreds of them. The program has never been funded at the scale required to cover the unmet need across Mississippi and Alabama, and the political economy of federal disaster mitigation funding, concentrated in the post-event recovery period, when appropriations attention is available, rather than sustained through the pre-event investment period when it is most cost-effective, means that gaps persist precisely in the communities most likely to experience the next event. The research on manufactured housing tornado mortality is not new. Dr. Brooks, Dr. Ashley, Dr. Simmons and Sutter, Dr. Klockow. The literature extends back decades and is in the textbooks of every meteorology and emergency management program in the country. The recommendation is consistent. Community tornado shelters, NOAA weather radio adoption campaigns, building code reforms for manufactured housing, and public outreach specifically targeting the nighttime warning reception gap. These recommendations have been made after every major Dixie Alley nocturnal outbreak, after the February 28, 2008 outbreak, after April 27, 2011, after the 2014 Dixie Alley outbreak, after every event that traced the same compound, manufactured homes, forest cover, nighttime warning, QLC's lead time. The people who live in manufactured homes in Hinds County, Mississippi, and Lee County, Alabama, and Pickens County, Alabama, are not making an uninformed choice about their safety. Many of them are there because they have no other affordable housing option. The manufactured housing stock of the DPEP South is not a product of individual risk preference. It is a product of housing economics, poverty, and the systematic underfunding of the rural South's housing infrastructure over generations. The vulnerability is structural. The deaths are predictable. The solutions are known. The investment has not been made at the scale the risk requires. That is the accountability statement that every Dixie Alley nocturnal outbreak eventually forces. Tonight, it is being forced again. We will be tracking every tornado warning issued by the Jackson and Birmingham WFOs through the night. We will be tracking the SPC mesoscale discussions as the squall line develops. We will report the first post-event casualty and damage assessments as they are released by MEMA and the Alabama EMA. We will be here for the storm survey results as they are published, the EF scale ratings, the track lengths, the path widths, the communities affected. We will be here when the accounting starts. Because the accounting from a Dixie Alley nocturnal outbreak at high risk parameters is not just meteorological, it is demographic. It is about who died, where they lived, what their house was made of, and whether they had a shelter to go to at 2 in the morning. It is about whether the investment in community shelters and NOAA weather radio and manufactured housing building codes that the research community has been recommending for 20 years has happened at the scale the risk required.
It probably has not. The current compliance and coverage data says it probably has not. And the people in the path of tonight's squall line are living with the gap between the recommendation and the investment. We will be watching. We will be here when the line passes. We will tell you what the instruments showed and what the damage surveys found and what the death toll means in the context of what was known and what was built and what was not built. The investigation and the accountability continues.